What is the program of today?
Knowledge
Today.
sharing. Yes. I think first I would like to open, or we'll start at 4 o'clock sharp. Then our chairman, let me introduce our chairman of the Indonesian Nuclear Society, Professor Susilo Widodo. He's already here. He will give the speech. Gimana Pak Susilo?
Selamat sore. Ya.
Selamat sore.
Dr. Supins.
Hello.
Thank you very much for your readiness for this speaking.
Yeah.
Yeah, it's my honor. It's my honor to be with you all, Excellency and the doctor and the colleague over here.
Pak Susilo, you can call him Pak Musa. He's Chinese Muslim, so everybody call him Pak Musa.
Yeah.
Like Prophet Moses, Musa. Okay, yeah, it's more familiar for us, I think. Yeah. And then after the speech by Professor Susilo, I will ask you to give the presentation about 30 or 40 minutes. Then we will have the discussion and question answers, and we will close the knowledge sharing at 5:30.
Okay, fine.
Yeah. Okay, thank you. And the members or the participants, as I told you, of the meetings, this knowledge sharing is very various, and mostly they are enthusiasts of nuclear technology, not only nuclear energy. So nuclear technology for the medicine, for agriculture, and many things.
Because you can see, as I before we had a meeting, I introduced China National Nuclear Corporation, all the nuclear industry chain. So no matter in the nuclear engineering, nuclear environment, in nuclear uranium, and also the back end process, and we have a full industry chain, and we have a full experience, and to look at the world, and since it's the first nuclear group which enter the Fortuna 500 in the world.
Okay. Yeah. Yeah, that's good. And there is Dr. Petrus Gunarso. His background is business.
Halo, selamat sore. Thank you.
Hello.
So maybe there will be a good future in Indonesia with the Chinese experience on nuclear energy, I think. Yeah.
Yes, of course.
Yeah. Usually the participant of the meetings in more than 100, so they will come late participate in this meeting.
Okay.
Yeah. So in a minute we will start the knowledge sharing. So your staff in here, only you and Mr. Simon in Jakarta?
Yeah.
Okay, that's good. Very effective.
Yes, maybe in the future once we have the equivalent project, and we'll increase the members or staff members over here.
Okay. Okay, we will start the meeting already 4 o'clock. I will mute all of the participants except who will give the talk and speech. Bapak Ibu sekalian, selamat sore. Assalamualaikum warahmatullahi wabarakatuh. Hari ini kita mendapatkan seorang tamu istimewa. dari China, dari Tiongkok, yang akan mempresentasikan pembangunan PLTN di Tiongkok. Tiongkok adalah negara yang sangat impresif dalam hal pembangunannya. Ada 20 pembangunan PLTN lebih yang secara serentak bersamaan dilakukan di sana. Kita pun satu belum bisa, mereka bisa melakukan secara paralel pembangunan PLTN lebih dari 20. Jadi boleh saya katakan pembangunan PLTN mereka itu terbesar di dunia, terbanyak di dunia saat ini. Dan ada potensi mereka akan mengekspor PLTN-nya ke banyak negara. Sekarang sudah membangun sampai PLTN ke-6 di Pakistan, dan mungkin sebentar lagi di Argentina atau di negara lain, atau mungkin Indonesia. Tapi sebelum kita beranjak pada fokus utama, kita akan mendengar pembukaan dari Pak Susilo Widodo sebagai Ketua Umum HIMNI. Please, Professor Susilo Widodo, you have time to give the opening speech.
Thank you. Terima kasih Prof. Jarod atas kesempatan ini. Assalamualaikum warahmatullahi wabarakatuh. Selamat sore dan salam sejahtera kita untuk semua. Salam sehat. Kali ini dari suatu tempat antara Jogja dan Kampung ini. Saya berdiri.
Oh, ini baru perjalanan darat ini.
Ya, di daerah main Senayu ya. Pertama-tama puji syukur marilah senantiasa kerjakan hadirat Tuhan Yang Maha Esa, Allah SWT, yang senantiasa memberikan kita nikmat yang luar biasa, nikmat sehat walafiat dan peluang, sehingga kita hari ini masih bisa bertemu kembali dalam acara rutin Kamis sore, yaitu acara webinar yang disponsori oleh HIMNI dan motori oleh Prof. Jarod dan Ibu Kenny. Dan sore ini, I would like thank to Professor Musa, Dr. Subin, for your readiness to deliver speak to us. I know that so far you have made or deliver speak to governmental organization like BRIN and other institution or Batan in the past, but today you are going to speak to us in front of non-governmental organization, HIMNI, and I hope that this will make spread all information to more people in our country. So, and then I hope that CNNC also will be known by larger people in Indonesia. And yes, greeting from Yogyakarta. Usually I stay in Jakarta, but today I am in Yogyakarta, and hopefully that during the next about 40-50 minutes, you will give us a lot of information about nuclear power plant development in China from the very beginning and until the recent status of the Chinese nuclear power plant, your development, and you now maybe you are enlarged, your expansion to introduce nuclear power plant not only in your country but in other country. Hopefully that we will also have a mutual cooperation to develop second of nuclear plant in Indonesia as well in the future. Baiklah, itu Bapak-bapak, dan saya kira terkait dengan latar belakang dan sebagainya, terkait dengan kiprah Cina dan sebagainya ini sudah disampaikan oleh Prof. Jarod tadi sedikit, dan mungkin akan ditambahkan lagi oleh Prof. Jarod, sehingga saya tidak akan menyampaikan lebih lanjut. Dan meskipun ini saya yakin dalam beberapa menit pesertanya akan melebihi 100, meskipun ini baru 72. Sini karena topik ini sangat menarik, saya sudah ditanyakan oleh banyak peserta yang sudah langganan ikut, kapan kok HIMNI minggu lalu kok tidak ada. Nah, kali ini yakin bahwa kita akan mendengarkan narasumber yang cukup saya kira cukup itu akan memberikan banyak informasi terkait nuklir power plant di dunia saat ini, terutama di Asia dan terutama lagi di China. Itu saja Prof. Jarod yang bisa sampaikan, lebih dan kurangnya mohon maaf. Billahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih Pak Susilo. Before we begin the main agenda, please see this video clip. Okay, let me introduce first Mr. Subin, the speakers of today's knowledge sharing. Mr. Subin is Chief Representative of Indonesia of Chinese National Nuclear Corporation Overseas Limited. And he always say that, please call me Musa. So Pak Musa, so it is very familiar name in Indonesia also. So hopefully during your stay in Jakarta, in Indonesia, you can communicate to everybody's, the stakeholders of nuclear community, energy community. And China, as I said during my opening speech, is a very impressive country on the constructions of nuclear power in the world. The number one, that capable to construct more than 20 NPP, maybe 27. You may explain later on. And Pak Musa is very experienced on the constructing NPP in Pakistan. He lived in Pakistan in 10 years. So you may ask him about many things about the export of NPP technology of China in Pakistan. So please, Pak Musa, give your presentation around 30 or 40 minutes. The time is yours.
Okay, thank you for Doctor, and thank you for all the friends giving me a good opportunity to introduce and to share the CNC, China National Nuclear Corporation, and the nuclear development in China, even our overseas experience. And my name is Subin, and you can call my Muslim name is Musa. And I'm a chief representative of Sinos in Indonesia. I wish in the future, under your support and help, we'll have a very fruitful cooperation in the future between Indonesia and China. Now, I would like to share with my PPT and to share all detailed information with our friends who are here. So, Dr. Can you see my PPT?
Yes, I can see it. Please show us the full screen.
This is full screen and already.
Oh, okay. Well, it's 91%. No.
Okay.
Yeah.
Now it's okay.
That's okay. Yes.
It's fine now.
It's fine. Yes.
Okay. So may I start?
Yes, please. You can start it now.
Okay. So China National Nuclear Corporation, we can provide the integrated solution for nuclear development, nuclear power development, and So let's come to the now. I would like to introduce our company, know more about us, CNC and Sinos. First, for the CNC is a China National Nuclear Corporation, a state-owned enterprise with nearly 70 years experience in the nuclear field. It's the sole party hold a company nuclear industry chain in China, and you can say we have almost 185,000 employees, and as a nuclear and the only nuclear which own whole nuclear industry chain. And we are first nuclear group to successfully entered Fortune 500, and we are stands and 381. And under the CNC, we have more than 1,400 subsidiaries, which is dealing with all nuclear and renewable and financing. And the total revenue of CNC is 39.05 billion by year. And for the CNC, as I said, that CNC has a complete nuclear industry chain. Over the nearly 7 decades since it was founded, CNC has acquired fully mastery of the entire nuclear industry chain, from the front end to the back end, which covers neutral uranium exploration, mining, conservation, and enrichment. And the second is nuclear fuel fabrication and nuclear power plant designing, construction, operation, and maintenance, and the nuclear radioactive waste disposal and spent fuel reprocessing, and the nuclear technology appliement in the different areas. And for the nuclear power development, as we are stands as the first rank of nuclear group, CNC has constructed many types of reactors from generation 2 to generation 4, which include CMP 300, CMP 600, CMP 1000, and HPR 1000. And also you can see the ACP 100 and HTGR PM. Those nuclear reactors is totally owned by the CNC, and it is fully have intellectuals by the designed and construct by the CNC. And also we can construct of VVER as ACP 100 can do 6. For the VVER, we have a cooperation with Russia in China as well. All Russian VVER reactors, which also constructed by the CNC. And the ACP 100 Actually, SCP-100 is from American. It's Westinghouse, and we have also imported the American power plant, but now it's in China. It is still under the construction. And by the end of May 2024, as controlling of shareholders, CNC has 26 units in operation, out of 57 units totally in China. And also CNC has 18 units under the construction or approved, which out of 36 units totally in China. And the CNC for the nuclear power development, CNC has adopted a three-step strategy for the nuclear energy development, which is thermal reactors, two fast and two fusion reactors, fusion reactors. You can see thermal reactors. We usually to say that it's a nuclear power plant, which we are using uranium-235. And we are on mutual technology and boundary constructed. And the second step is for the fast neutral reactors, which we are using uranium-238, and which has a high utilization rate of uranium resources compared with thermal reactors. And also we for the fast neutron reactors, which can use a spent fuel gradually reduced. And the third step is fusion reactors. Fusion reactors, it is the first in the world, and it has a deuterium and tritium, and which also has high thermal efficiency, no risk accident success, supercritical or fuel mandatory. And come to the CNOS, and the CNOS is founded on the April 25th of 1983, and China, which called China National Nuclear Corporation Overseas Limited, which wholly owned subsidiary of CNC, its leader and designated platform specialized in overseas market development of a complete nuclear industry chain. And for CNOS, and we can provide integration solutions based on the nuclear industry chain of CNC. CNOS can provide lifestyle integrated solutions for overseas NPP. And as you can see here, the CNOS as a leaders, and we are overseas EPC contractor, no matter for the nuclear power or research reactors. And also under the leadership of CNOS, we have CNP. CNP is an overall designer. And we also have a few supply company which called CNEIC. And after that, we have a specialized company for the nuclear construction, which called CNEC. And we also have a NSS steam turbine design company, which called NPIC, and we also have our specialized operator and OMM services for the nuclear power plant, which called CNP. And now I would like to share the overseas project. Over the last 40 years, CNOS has successfully exported one research reactors to Algeria and 6 nuclear power units to Pakistan. And also we are jointly jointly with Pakistan to build 6 nuclear power plants. We have successfully established 2 nuclear power bases, and one is Chashma nuclear base, and the second is Karachi nuclear power base. In Chashma, we have built 4 units, and each unit are 340 megawatt. And in Karachi nuclear power base, we are adopt a 3rd generation, which called HPR 1000, and each unit are 1100 megawatt. and compare with to see all 6 units in Pakistan were complete within a budget, ahead of schedule, and operated by the owner safely and stable. And meet with your power demand with our delivery capacity. And for the designing of HPR 1000 over the 40 years of experience in design, engineering, and operation has endorsed us with HPR 1000, a safe, reliable, economic, competitive 1000 megawatt level PWR reactors technology independently developed by the CNC with a combination of active and passive design concept. HPR 1000 has completed the GRSR safety review of IAEA. For the HPR 1000, we have several technology features, which you can say is advanced generation 3 PWR. And also we adopt active and passive safety system. And for the reactors fuel, we have 177 fuel assembly. And also we designed in the single unit layout. And for the reactors, we are adopt double shell containment. And also design basic on the Fukushima feedback. And we have designed HPR 1000 with the most advanced and safe design. For plant of HPR, you can see that here my right side is a picture of Fuqing nuclear power base in China. We have successfully built first third generation HPR 1000 in Fuqing, which called Fuqing 5 Unit 5 and Fuqing Unit 6 in Fujian province of China. And for the Fuqing 5-6 installed capacity is 1161 megawatt. Design life is 60 years. Refilling cycle is 18 months. Availability factors is more than 90%. As the safety shutdown earthquake, it is 0.53. For the Fuqing 5, we have FCD time, you can say that since 2015, and Fuqing 6 also in the same year. And the COD, we have successfully got COD for Fuqing 5, it's 2021, and the Fuqing 6 in 2022. And the construction period of Fuqing 6 is 68.7 months, and Fuqing 5 is 75 months. And the annual capacity factor of Fuqing 5 is 92.04, and Fuqing 6 is 91.61. And you can see all milestones of Fuqing 5 nuclear power plant in China. And after Fuqing 5, and we have built another 2 nuclear power units, which also adopt same technology, which it's HPR 1000. But according to the Fuqing 5 and 6, and we have utilized our design and cost as well. You can see on the Fuqing, you can see in the Zhangzhou Unit 1 and the Zhangzhou Unit 2, we have improved installed capacity up to the 1212 megawatt, and the design life is 60 years, and the refueling cycle is 18 months. And FCD time is 2019, and COD time, planned COD time is 2040, by the end of 2014. And Zhangzhou Unit 2 will be got commercial operation by the October 2025. The both units construction period has been reduced 62 months. And now we'll come to the overseas plant of HPR 1000. The first 2 overseas HPR 1000 units has come into operation in Karachi, Pakistan. And the EPC contract of another 2 HPR 1000 units has been assigned. One is in Pakistan, in Chashma nuclear base, which we call the C5 project, and the design capacity is 1200 megawatt. And another one is Argentina, Achatu Unit 3, and we have signed a contract with Argentina on 2022 February 1st. With the information of overseas HPR 1000, and for one unit, 1 unit construction period, we are required for the 66 months, and for double unit, 2 units, we are required 87 months of construction period, start from FCD to COD. The unit capital cost of 1 unit of HPR 1000 it's around 4,500 to 5,500 US dollar by kilowatt by hour. For 2 units, we can slightly reduce the cost, which comes to the 4,000 to 5,000 US dollar. And you can see that the picture on the show over here is Karachi nuclear power unit 1 and unit 2. For overseas MPPs, the capital cost will be estimated as by the local laws and regulation, infrastructure, equipment, construction, material supply capability, and site condition. CNOS will assist the all-conduct economic study during the feasibility study stage of nuclear power plant. And design of, now we'll come to the design of HTR. The purpose bed modular high temperature gas cooled reactor, which we call HTGR PM, is advanced nuclear reactors with characteristics of generation 4 nuclear power technology with independent Chinese intellectual property. Here, I would like to mention that currently regarding HTGR PM technology, advanced reactor technology, which also start cooperation between the Chinese Tsinghua University and BRAIN. Under the 2 governments support, the Tsinghua University and BRAIN has established the HTGR PM Research Center in BRAIN in Jakarta. For HTGR technology, we have several features which call inherent safe, online refilling, multi-applications, and modular design. For the characters of HTGR PM, it's helium cooled graphite moderate reactors with a fully ceramic coated particle surface fuel elements. It's featured with a low power density, controlled reactivity, confinement of radioactive material. You can see it is all design of fuel of HTGR, which is a ball shape and which can be online refilling at any time. And the control of reactivity, we will say that full scope navigates temperature feedback, reactor shut down automatically, online refilling allows less excess reactivity. Confinement with radioactive material, triso particles coated with 4 layers of high temperature resistance material. Multiply barrier allows sound confinement of radioactive. fork plant of HTRPM. Actually, in China, we have built first fourth generation nuclear power plant, which is HTRPM, and we have our demonstration plant. The first demonstration plant in the world has been successfully got into commercial operation in Shandong province of China. The installed capacity is 210 megawatt. Coolant helium's pressure is 7 MPa. Reactor outlet temperature is 750. Main steam temperature and pressure is 541 and 13.9 MPa. Design life is also 60 years. Applied for the power generation, and we have got FCD from 2012 and got commercial operation is 2023, and the construction period is 132 months. And petrochemical come to the HTR 600 PM600. We have successfully linked and petrochemical couplings. The demonstration project, Lianyungang Nuclear Steam Supply Project, for the petrochemical couplings plans to supply industry steam to the Lianyungang petrochemical industry base. And we can see that the project planning four units at HPR 1000 plus 2 HTR PM600. And phase 1, we will plan to construct 2 HPR 1000 units plus 1 unit HTR PM600S. The phase 1 steam supply is 4,000 times by the T by H, and thermal utilization rate is more than 85%. Planned FCD is December 2024. You can say this is all detailed information. And for the HTR plan, single unit, the construction time is 48 months, and the unit cost is 6,000 to 7,000 US dollar per kilowatt by hour. And HTR PM600, the construction period is 60 months, and the cost has been compared with HTR PM. It's slightly reduced, comes to the 5,000 to 6,000 US dollar per kilowatt by the hour. And the design, now we are coming to the SCP 100. It's a design. It's a small modular reactor, and the SCP 100 is a new generation of small and elegant MPP developed on the functional of inherent mutual technology aimed at boundary user and featuring with easy connected to the small medium size of power grid, urban regional heating supply, industry process steam supply, and seawater desalination. For the SCP 100, and we have several technical features, which we can see that we have advanced integrated reactor and a passive design of safety system, mighty applications, and also it adopts modular design. And the picture is first SMR reactors developed, construction in China, Hainan province. The characteristics of SCP-100 is adopt integrated reactor design technology along with a passive system, safety system, incorporating comprehensive measures for preventing and mitigating services accident. You can see that for the SMR integrated design, we are scanned bomb connected to the IPV. Once through steam generation and integrated reactor handling design. And for the Volk plant of SCP constructed in China, which is located in the Hainan province, and the installed capacity is 125, design life is 60 years, refilling cycle is 24 months, availability factor is more than 90%, safety shutdown earthquake is 0.3 G, COD time is 2021, and the planned COD time is end of 2025. Construction time is 53.5 months. And this is a multi application. SCP-100 is aimed to the bundle use feature ring with easily connected to small, medium-sized power grid and the heating supply, industry process, steam supply, seawater desalination, and the floating nuclear power. Refer to information of overseas SCP-100. So for the single units, the construction period probably is around 48 months, and the 2 unit is 60 months. The cost of SCP-100 for single unit is 8,000 US dollar to 10,000 US dollar per kilowatt hour. For the 2 units, we have reduced the cost. It comes to 6,000 to 8,000 US dollar. And the construction of CNOs by the end of May 2024, while CNC's subsidiaries CNEC has successfully constructed 63 MPPs, which included domestic in China and overseas, which access multiply reactors from 125 megawatt to 750 megawatt, and has the capable to build up to 40 MPPs simultaneously. This is the construction capability. CNEC has developed serious advanced construction technology and successfully completed construction of world first HPR and EPR, and also SCP-100. And the supply chain, CNC nuclear supply chain ensured reliable and diversity in equipment supply through the evaluation, optimization of China, global and local suppliers. Resilience supply chain, which included a three-part China supply. Qualified supplies can be supply 100% of nuclear power equipment, such as IPV, SG, pressurizer, ICP, premium piping, turbo generator. Global supply, qualified supplies can be supply ICP, DCS, EDG, I&C instruments as by the owner's requirement. Local supplies will be evaluated, and promotional activities will be carried out to optimize local participants in the new MPP's construction. Financing solution. So for the export credit agency facilities has been utilized in MPP unit export to Pakistan successfully, which can provide stable and sustainable financing support. Financing close can be realized within 1 year on the basis of sovereign credit. You can see we have a mutual financing solution. China finance institution can provide maxed financing support for overseas MPP construction, including concessional loan, preferential bias credit, commercial loan. Financing amount can be up to 85% of EPC contract. It depends on the Chinese export share. Financing terms of ECA facility currently is 20 years, including 8 years grace period. Moreover, CNC can participate in morality, equity investment in the project company according to the owner's requirement. Other financing solutions can be also discussed as by the owner's requirements, such as BOT, and the interest rate will be depends on the credit structure and will be fluctuated as by the marketing. Currently, if financing currency is RMB, the interest rate could be around 4% on sovereign credit. And we also have human capacity building. More than 40 universities offers nuclear program in China. CNC Nuclear Industry College also can provide training for the global customers. CNC has trained more than 5,000 operators and established a complete training system in line with the industry standards, which we can say that systematic training. CNC utilized systematic approach to training, which called STA, to ensure effective training for the personnel, and has established a complete training system fully applicable to be both domestic and overseas. Training resources, which nearly 1,000 professional instructors, and a comprehensive training program, operating training centers, skills training centers, nuclear vocational skills evaluation center, full scope simulator for HPR 1000, AP 1000, M321, CANDO U6, and VVR. And for the training content, which included 19 infrastructure issues and the nuclear regulatory system, pre-project working, design, manufacture, commissioning, operation, O&M, operation and maintenance, and also simulator training. University education program supported by the CNC, Atomic Energy Scholarship Program of China, Tsinghua University International Master Program in Nuclear Engineering and Management. And we are granting you your life cycle fuel demand with our fuel cycle system. You can see that CNC has proven experience in neutral uranium exploration, mining, conversion, enrichment, advanced fuel fabrication and trading, spent fuel dry wet storage, spent fuel reprocessing. And we also can provide uranium exploration, mining, conservation, and enrichment. For the uranium resource exploration, CNC is equipped with the world-class space, airborne, ground, underground, integrated comprehensive exploration capability, and can quickly carry out geographical data processing, interpretation, analysis, and evaluation of mineralization geological condition. For the uranium mining, CNC is also recognized as a global leader in the oxygen cargo and oxygen in the situ leaching uranium mining technology, with track record successful large-scale industry applications. Uranium conservation and enrichment, CNC is capable of realizing uranium conservation and enrichment, and to obtain uranium dioxide for the fabrication of nuclear fuel pellet. Fuel fabrication and the CNC processes advanced technology for the manufacturing nuclear fuel assemblies for various reactor type of such as HPR 1000, CMP 1000, AP 1000, VVR, CANDO, HTGR, and the SP100. And we have our professional field web fabrication, setup, manufacturer, workshop. And for the spent fuel, the CNC spent fuel management is a complicated and regenerates process involving in the multiply stage, each with a specific purpose, technology requirements by the scientifically and reasonable managing spent fuel. Radiation risk can be efficiently reduced. Evaluation resources recovered and environment impact minimized in the spent fuel. You can see the picture. We have stuff from wet storage in the spent fuel pool to the dry storage in interim storage in the dry storage facility over the past 40 years. And we also can provide supporting services for radioactive waste management. And in the area for radioactive waste management, since it adopts advanced proven treatment processes for all type of waste to ensure radioactive waste minimization, since it is capable of providing customized services covering the whole process from planning, site selection, construction, commissioning to the operation. So for the radioactive waste management, since adopt advanced and proven treatment process for all kinds of waste to ensure radioactive waste minimization, which we can have three areas. First is liquid waste treatment, and also solid waste treatment, and innovative technology. Radioactive waste disposal, since it's capable to provide with a whole process starting from planning, site selection, construction, commissioning, and operation. And you can see this is all disposal repository in China. And with all nuclear power development experience in China, since it has very great confidence to work with our international friends and partners to build most advanced and safe nuclear power technology in the world. So getting the green electricity with the nuclear power and our integrated solution. Okay, thank you very much for all friends. This is all my introduction about CNC. And I hope that under our joint efforts and also your support, we can build a successful and along with a fruit results in coming future in the area of nuclear power cooperation or research reactors between Indonesia and China. Thank you very much.
Thank you very much, Pak Musa. Well, it's very impressive presentation, and I think CNNC is very busy organization or company because you construct many NPP at the same time. So my questions regarding about the NPP construction. First, I have to explain that Indonesia have a plan to reach the net zero emission in 2060. One of the solution and can give the contribution using the nuclear power plant. And the National Energy Commissions already announced that we will have the NPP, first NPP in 2032. It means only 8 years from now. It's very a short time. But you show us that during the construction in Pakistan, you show us that always ahead of the schedule. It means it means no delay, almost no problem at all. This is very good information for us. So my question is, well, maybe the average from the opening of the project until the commission or the operation of the NPP is around 7 or 6 years. This is my first question. The second question, is there any problem during, well, you have experience in Pakistan 10 years. Is there any problem with, for example, with anti-nuclear movement or about the social political issues? Yeah, we find many here. How about the challenge in Pakistan on the constructions of the NPP? This is the first two questions from me, and then maybe the audience will ask you. Please.
Okay. So I will first thank you very much for your question, and you can see that we have successfully exported 7 units in Pakistan, and we have been successfully cooperated with Pakistan since last 30 years. For you can see for the overseas plant of HPR 1000 for the Karachi, all units which we are building in the Pakistan, all construction period are ahead of schedule. There is no delay. There is no delay for any plant, and you can see here. I can show you that data over here. That for the first unit we built in Pakistan, the schedule 1 day before the schedule, and for second unit we are advanced almost 3 months, which we can say is 111 days ahead of schedule. For the third unit, we are ahead schedule of 27 days. For the fourth unit, we are ahead of 36 days. For the third generation, which we are constructed in Karachi, generation 3 HPR 1000. For the K2 unit, we are ahead of 9 days. For the K3, we are ahead of 12 days in Pakistan. We actually for the HPR 1000, as by our experience, you see in China, compared with China, the overseas the construction period is longer than overseas than domestic. You can see that the domestic construction in China construction period is 68 months, and in Pakistan we spent 69 months. There is no much difference, only a few days difference. And for K2 units, we almost K3 units we almost spend 70 months. This is the overseas construction period of HPR 1000. For the challenge, I think it is from several aspects. First is overseas the Pakistan political stability. I mean the government stability, because nuclear power plants has to be got government approval. If there is a stable government along with a stable policy, then for the nuclear power plant will be success. Otherwise, it will be a great hurdle for nuclear power plant. And the second is coming for the other energy resources like hydro, coal, and renewable. Actually, Pakistan, they are adopt competitive mechanism. So they are compare all kind of power energy resources. Which one is the most economic? They will select and they will prefer for that. And also, as by the global change, most of the country, they are interested in renewable. So of course, the renewable is cheaper than nuclear power plant, but there is a difference. As nuclear experts, we always say that as a coal-based load of country energy structure of nuclear power, we cannot compare the nuclear power with renewable, because there is different reason. You can see that once nuclear power plant put in the nuclear fuel, they're continuous running for the 18 months without any issues. So for the hydro, there needs enough water to push steam to running, and if the water is in peak time in the rain season, they have reach water to supply, then they will generate more electricity. It means they are also, the hydro is not stable, and for the coal, it is a kind of a base load, but for coal you also need import from the foreign country. Sometimes due to the shipping issue and the customer issues, it will be also not stable. As by the current international global market, the coal price is unstable, and it is the cost of coal is a continuous increase. It will be impact the electricity price. For the renewable, of course, you see the wind and the solar. The wind, if there is a wind, you will generate electricity. No wind, no electricity. And solar, there is sun shining, will be generated electricity. Without the sun shining in the evening, you cannot have power. And another challenge is the safety, because in Pakistan the safety issues is always impact the development of energy project. Okay, that's all challenges.
Thank you.
Yeah.
So it's mean almost nothing the anti-nuclear movement or the sometime like in Indonesia we are suffering well, we are experiencing about the anti-nuclear NGO or something. In Pakistan, it seems to me there are no
in Pakistan, for the Pakistan citizens, they actually, our partner and the Pakistan Atomic Energy and even the government, they are recognized the safety of nuclear power plant, and also they have given the hearing for the public, and the public also accept the realized and recognized the safety of nuclear power plant. And in the consideration of environmental, the Chinese technology, CNC, HPR 1000, no matter second generation or third generation, we are fully advanced in the world, and all environmental issues we are standing in the standards policy, and we are fully followed international environmental regulation, all Pakistan country environmental regulations.
Okay, well, thank you. We envy Pakistan, I think, because it means they go smoothly on the construction of the NPP. And this table in your slide show us that during the COVID-19, during the pandemic, you worked continuously to finish the project, isn't it? Because COD is 2021 for the Karachi 2, and Karachi 3 is 2022. It means during the pandemic, you still worked to finish that project.
Yeah. Actually, you see, for the we have been very mutual trust with our partner in Pakistan, and by one side, we are prepared. We have fully prepared for any. Before we construction of a nuclear power plant in not only in Pakistan, other country as well. Before we construction of nuclear power plant, we have a precaution of all kinds of accident during the construction. So we have a very confident margin to overcome the all accident, even in the pandemic, COVID-19. So we have impact. We have hardly impact by the COVID-19. But even though we are overcome the accidents and the risk of COVID-19, and we are reach the construction ahead of schedule. If we are quite confident, if there is no COVID-19 accident, our construction schedule will be much ahead of schedule.
Oh, okay, that's very impressive. There is one question from Pak Mahendra Ristanto. Pak Mahendra would like to ask directly to Pak Musa, or should I read your questions? Okay. I think Pak Musa, please unmute yourself. You can ask directly.
Oh, yes, please.
Oh, Pak Mahendra, please. Pak Mahendra, sorry. Silakan Pak Mahendra.
Okay, thank you, Mr. Jarod and Mr. Subin. Great explanation from you and from CNNC. My question is Unit C1, type CNP 300 in Pakistan, which COD and 2000. It was operating around 24 years. My question is the unit still operate well? Maybe is there type of maintenance you should show to us? And the second question is when the unit will be entered to disposal era. We know its power plant by design will be approximately 25 or 30 years until disposal. But maybe nuclear power plant difference, and we want to know nuclear power plant when to enter the disposal era.
Okay, Pak Musa, will you please to answer? Yeah.
Okay, I first answer the first question regarding the OEM in Pakistan. Actually, now all six units in Pakistan are running and stable and safely. And especially, I have to mention that like the C1, C2 unit, they have successfully reached to the continuous running for the 384 days. And for the OEM and for K2, K3, in the first quarter of 2014, those unit has got full marks of 1 record. So Pakistan has a very professional operation team, which is under our training program. Before nuclear power plant construction, we have a training more than 50 students from Pakistan, and we are training designer, construction engineer, and commissioning engineer, and operators. Now, for Pakistan, they have totally owned second generation operation technology and the third generation units operation technology. Now, under our support, they are owned by themselves, and the plant are running safely and stable under the IAEA review and the WINO review. And for the maintenance of Pakistan unit, since last 30 years, and we, in order to make sure the safe and stable operation of a Pakistan unit, CNC also established O&M company specialized to operate, to conduct the operation and O&M services for Pakistan. But as the last 30 years cooperation, the Pakistan now also they have their own O&M team, and they also can conduct O&M services by their own hands. And for the fuel, the Pakistan has established a dry storage after finish of fuel, and they shift spent fuel to the dry storage and to store under the ground. And for the plants which is going to nearly to getting the retirement, actually in Pakistan they already have another Kandu unit which is also got retirement, and now it is also under reprocessing stage, and also Pakistan can conduct by themselves. Thank you.
I think the question from Pak Mahendra is the first. The C1 is still in a good condition, isn't it?
Yeah, and the C1 is still in the good condition. Here we are mentioning the installed capacity is 300, but actually C1 is running in the good condition along with the 340 megawatt.
Okay. And the second question is the operation lifetime for the C1 is scheduled for 40 or 60 years?
40 years.
40 years. So
yeah.
It means still until 2040, isn't it?
Yeah, you can see that C1 to C4 is the second generation, which called CNP 300. It's a second generation technology from CNC. The design life is 40 years.
Okay, ya. Masih ada lagi pertanyaan Pak Mahendra? Cukup? Oh ya, terima kasih Pak Mahendra.
Cukup, terima kasih.
Yeah. There is a question from Pak Erickson Marbun. Pak Erickson would like to ask directly to Pak Musa, or should I read your questions? There is a question from Pak Erickson Marbun. How many waste, it means radioactive waste, that your country has produced or generated? Well, this is a good question. Hopefully you can explain it, because you have many NPP, and Pak Erickson asked you about in many years in operation of the NPP in China, how many radioactive waste already generated, and where is the waste, and where do you want to dispose, maybe? Please answer the question.
You are asking how many operating units in China, right?
No. How it means the quantity of the waste that already generated by the NPP in China. Maybe you can answer roughly about the volume.
Actually, for the waste of NPPs, of course, you see, now in China we have 57 units under operation, and for the waste of spent fuel, the number of spent fuel, really, I'm sorry, I have no idea. It is I can get feedback to you later on, because we we are not focused on the actually I'm not in the government bureau for investigation of this data.
Okay.
I can get feedback you later on.
Thank you. There is one question from my partner at my house. So, Bugeni, please ask by yourself. Bugeni?
Thank you. Sorry, I cannot open my cam because I'm doing something. Yeah, my question is, as you know that the cooperation to build the NPP needs a long periods, maybe more than 10 years or more than that one. And then I want to know, according to your experience when the China built the NPP in Pakistan, how is the China company ensure the long-term operational sustainability of the NPP in Pakistan, and what is the most challenging point on that? Thank you.
Yes. How to make sure the nuclear power is stable and continuous running. Actually, in order to make sure, and we have established specialized company for O&M and to supporting Pakistan to running nuclear power plant as well. But we are only stands in the O&M support and the operation support. We are providing our expert to Pakistan whenever they have a requirement. We will give them the consultation and we will help them to resolve the issue. But currently, as by the capability of Pakistan nuclear power industry, they are all to operate by themselves. And by the way, how to make sure in the operation. So we have jointly we have a commitment with Pakistan, and also Pakistan they are strictly follow the instructions of nuclear power unit operation procedures. And also they are under the review of IAEA and the WANO. And there will be, I think currently for the challenge, there will be no big challenge. The only challenge is that the great instability of Pakistan, because they have different resources of electricity energies. So also their grid it's not much performed. So most of the time, due to the great instability, impact nuclear power to shut down. So this is the only operation challenge in Pakistan.
Bugeni?
Yeah, thank you.
Yes.
That's enough.
Okay, thank you, Bugeni. And there's another one question from J. Malisan. I will read it. Indonesia and Pakistan may be similar politically and geographically, but their people's perception of nuclear power may be different. What is the Pakistan people's view of nuclear power and its future?
Sorry, could you please repeat?
Okay, maybe Indonesia and Pakistan have a similar politically and geographically, but their people perceptions, the Pakistan people perception on nuclear power may be different with Indonesian people. What is the Pakistan people view of nuclear power and its future?
That's a good question. Actually, Pakistan, first for in Pakistan, they have a nuclear laws, and the government has first of all I will answer in the government level. Actually, government they have a very strict laws and policy in the nuclear construction and operation. Even in the whole nuclear power from starting to the back end, they have a complete system, and they have also established atomic energy and regulator body, and also they have a very good safe and response agencies in Pakistan. And the second, the government they knows the importance of nuclear power program developed in China as a strategic project for country, because it can improve and secure the country's energy structures safety. because it is a base load. And the third one is the Pakistan government. They have a very good policy to communicate with the citizens, peoples in Pakistan. They introduce and they make announcement to the peoples of Pakistan, and to come whenever they are going to launch a new project or nuclear power project. So they used to have a very scientific introductions, and also they give the feasibility report to the citizens to know how is a nuclear power plant, and how is technology of nuclear power plant, and how is the construction, and how is the operation, how is the safety of a nuclear power plant. And by the way, that's whenever they are studying, they're always holding the hearings and to hear about the suggestion and the ideas from people of Pakistan. And they always have a very friendly environment, and the people are support. Actually, in Pakistan, people are support nuclear power program, and because people, they knows the whole importance to the country, how importance to the energy field, how importance to develop industry, because nuclear power plant, they are not only generation electricity, they can only improve the nuclear industry development, and also they can create the job opportunities to the Pakistan people, and they are given the good benefit to social development as well.
Okay.
Thank you.
Thank you, Pak Musa. Well, this is my personal opinion. I think Pakistan have a competitor with the neighboring country, India. So
Yeah.
they compete each other. If India have, then Pakistan have. That is maybe the natural competition among them. Well, very long history. And both countries is non-NPT country. They don't ratify the non-proliferation treaty. It means they also compete on the nuclear power. I don't know for sure, but it seems to me, and they don't have any wide options on the cooperation with other countries on the nuclear energy program, I think. So China is maybe the country that can help the Pakistan. And why somebody's China built 6 NPT. The question is maybe because the situation different with us, Indonesia, we don't have any competitor in our region. Maybe I don't know, Pakistan, Philippines or Malaysia, they are not our competitor. And another questions from Pak Sarvi. Please, Pak Sarvi, unmute yourself.
Doctor, I would interrupt you that
Sure.
Your idea, your stance, it's right, but in the physically, all the people, all the country will consider that Pakistan has a competition with India. Of course, they have a competition in every areas.
Okay.
But the Pakistan government and also Pakistan atomic energy, they realized that what importance of nuclear power plant and what importance of nuclear power development program, because it is they have determined as a strategic project for country. So by the way, there is a structure and mechanism different between Indonesia and Pakistan. Actually, the Pakistan Atomic Energy Commission, they are a government body to develop, to research, develop, construction, operation, all the nuclear power plant and the nuclear reactors. So they have a power to develop. they have a right to develop, and they are not belongs to government ministries. They don't belong to any ministry. They are belongs to the army, and above Pakistan Atomic Energy, they belongs to army. So they have a very quick decision, and they have a very quick recognition of the whole importance of nuclear development. This is the difference between Pakistan and Indonesia.
Okay. There's another person who will ask. Pak Sarwi, please, Pak Sarwi.
Thank you, Pak Jarod. My questions is regarding the capital cost compared to the coal-fired power plant, Pak Mr. Musa. In your slide, page 14, if I'm not mistaken, I got the impression that the capital cost for this nuclear power plant almost double compared to the coal-fired power plant. Is that correct?
You can say, I think it's not correct. And you can see that I'll give you the example. In Pakistan, the coal power plant depends on the import coal or local coal. If you compare with the local coal, no matter in Pakistan or Indonesia, local coals, the unit cost is around 2,500 to 300 US dollar per kilowatt by hour. And if you come to the imported coal, it will be around 3,000 to 4,000. And it is almost same with the nuclear power plant. But you can see, to look at long term, you see coal power plant is the design life is 30 years, and the nuclear power is 60 years. And also you see that the fuel price, you see currently due to Ukraine war and the Russian war and any other international conflict, the coal price is not stable. Sometimes higher, and especially in these years, the coal price is high. But nuclear fuel price is stable. And the second, the third one, you can see that to look at long term, the nuclear power plant tariff, it's much cheaper than coal power plant. Yeah. So this is my answer. And you can also to compare, you can research different information from data from internet. And for Pakistan, before we are starting the new project, and some some ministries also arise same question, and they say the coal power plant is cheaper than nuclear power plant. Actually, it depends. If you compare with the local law, local coal power plant is cheaper. But if you compare with the imported coals, and it's almost the same with the nuclear power plant, as I give you the unit cost. And also, please do not look at only the unit cost. If you go for the long-term design life and average tariff, and also stability and the O&M cost, the nuclear is much cheaper than coal power plant.
Yes. All right. Thank you.
Yeah.
Thank you, Pak Jarod.
Pak Sarwi, terima kasih. Thank you. Thank you very much. My question is to Pak Musa. Is there any competitor in China besides CNNC? Maybe you have another company that also construct the NPP, like CGN or something?
Yes. Yes, you are right. We in China, for the company which has qualified license for operation of a nuclear power plant are three companies. One is CNC, and one is CGN, and one is SPIC. Actually, CGN is come back to the 20 years ago. CGN belongs to CNC. It is due to economic development, and the government has sublet CGN from CNC. But for the CGN and SPRC, they are only nuclear power operator. They only have a nuclear power plant, and CNC is the only nuclear company which owns whole nuclear industry chain, started from uranium mining, enrichment, and nuclear power plant construction, operation, and decommissioning, and also the fuel decommission and the bank end process, which is all owned by the CNC. For the SPRC and the CGN, they are nuclear power operator, and their nuclear construction, nuclear power plant construction is also constructed by the CNC team, and their fuel, nuclear power plant fuel, is also supplied by the CNC.
Okay.
Yeah.
Well, and this is my last questions. In the slide 35, you show us that there is a possibility that China take back the spent fuel from the country that already import the NPP from China. So in the case of Pakistan, do you have a contract to take back the spent fuel from Pakistan to China?
No. All spent fuel belongs to Pakistan, and Pakistan,
really?
they will manage by themselves. Yes.
Okay. So it's mean, but there is a possibility, according to the contract G2G, that if, for example, Indonesia would like to build the NPP, then there is a special contract that you can take back the spent fuel, isn't it?
I'm not sure it is currently in Pakistan, in China, as by the Chinese government law, that we are not allowed to bring the spent fuel back to the China. But I don't know whether in the future maybe there is a possibility. It depends on the different situation.
Okay. So would you please show us the page 35?
35.
Yeah. It's very interesting because there is I forgot the 35. So this one, after interim storage, spent fuel can undergo reprocessing for overseas NPPs exported by CNC. Spent fuel can be returned back to China based on the is it?
After interrelated storage, the spent fuel can be undergo reprocess. For overseas NPPs exported by CNC, spent fuel can be returned back to China based on the G2G agreement, Chinese law and regulation. This can be returned. That the condition of return of spent fuel, it must get interim storage, and spent fuel can be under cargo reprocessing. Yeah.
It means that if we want to reprocess our spent fuel, if you have the NPP, then we can to carry the spent fuel to China, and you reprocess it, and spent fuel can be returned to China, isn't it?
Yeah.
Okay. But in the condition that we have to reprocess that spent fuel. Okay.
Yeah.
Okay. Thank you. Okay. I think the time is almost 5:30, although some questions still many that later on, I will send it to you some questions that I cannot read it. But anyway, if you have any, closing remarks about your presentation today, maybe the optimistic views of the future, the cooperation between Indonesia and China, please.
Yes, all doctors and dear friends, and here I have to emphasize regarding the cost, regarding the Chinese nuclear power technology. Now we are confident in the third generation or fourth generation or SMR reactor. We are leading the world industry in the nuclear industry, and also we have no matter in the third generation, we have a demonstration plant. Also, we have an overseas plant, and for HTGR PM reactors, we also have a demonstration plant. For the SMR, we also have a demonstration plant. It means we are leading the nuclear areas, nuclear power in the world, and we are confident our technology is most advanced and also approved by the IAEA and WANO. So we as I can share that in the WANO record, in the top 10, almost the top 10, the nuclear power operation in the world, the China has occupied more than 7 to 8 top 7. It means China nuclear power technology stability and operation also in the good advantage. And also I have to say that one important is that consider safety and advanced technology and also cost economic. So CNC and China nuclear power plant compared with Russian, Korea, American, and France, we are more capable. And compare the price with the foreign country, our gap between China and the other Russian and other country, we have 3,000 to 4,000 US dollar by kilowatt hour. So I would say that Indonesia is a very great country, and you have a great emotion to develop nuclear industry, and you also have your own research, and you also have a lot of experience in the research and also other plants and nuclear technology appliement. I am confident, I believe under our joint efforts, and in the future we will have very great fruitful cooperation results in the future.
Okay. Thank you very much, Pak Musa. Thank you for your explanation and many things. Well, I forgot to tell you, we are also interested in the SCP-100. I forgot to ask you, but anyway, later on, I would like to invite you in this webinar also. Because according to the National Energy Commission, if we want to have the NPP in 2032 or 2033, so we will operate as small modular reactors. The option of small modular reactors in the world is, it's very small. Only small numbers of SMRs is already in operation and nearly in operation. That's why SCP-100 that you said in next year will be commissioned and maybe in operation in next year. One option that we can say it's proven technology. Hopefully some days I can ask you or invite you in this knowledge sharing about the SCP-100.
Okay, fine. So we for the SCP-100, according to Indonesia, it's a good choice to select SCP-100, and it's a modular reactor, more safe, more stable, more advanced technology. And for SMR, I want to explain, if you willing, that it has multi-function. SMR can generation electricity. SMR can supply heating to the city. SMR can generate steam to the industry. SMR also can desalination of seawater, and SMR also can installed in the icebreaker and the floating nuclear power plant.
Okay, okay.
Mm.
Anyway, thank you very much, Pak
Thank you.
Musa. Hopefully, we can invite you sometime in the next time. Okay, thank
Okay.
you. Terima
Okay,
kasih.
thank you.
Thank you. Terima kasih Bapak Ibu sekalian sudah berkenan mengikuti acara kami, dan moga-moga minggu depan kita akan mengundang untuk tema yang berbeda dan sama menariknya dengan apa yang disampaikan oleh Pak Musa hari ini. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh. Thank you very much.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih banyak Bapak Ibu.
Terima kasih.
Terima kasih
Terima
Profesor
kasih.
Jarod.